All right, hello. Today we are going to start 4.2, which is titled Regression, which is line of best fit, and prediction on that line. To get started with today, make sure you are in the 4.2 student notes. If you can print them now, pause the video. If you want to just have them up, make sure they are up, but we are in the 4.2 student notes. So, prediction and regression. Let's see what that really means. A regression line is just laying a straight line that describes how a response variable changes as an explanatory variable changes. So up to this point, we have scatter plots. And on the scatter plots, which are just points on a graph, we find the correlation of those. And so the correlation is the strength of a straight line relationship. To start 4.2, we find the actual equation of the line. We find the line of best fit. Because once you have a line of best fit, you can predict values of y for any given value of x, even if it's not in the data you originally got. So we're just adding the line of best fit today and using that line. This slide tells you how the process works, but look at the bottom right away. Luckily for you, we use the calculator to actually calculate our line of best fit. The line of best fit has a name. It's called the least squares regression line. And the reason it's called least squares is because if you look at these purple dots, each one of these is a point on the scatter plot. The way that the computer or calculator decides where does this perfect green line go, it's not just a guessing game. It takes all of the points that are going to be below the line and all of the points that are going to be above the line, and it squares that black line, the vertical distance. That vertical distance is called a residual, but it squares it, and it makes it so if you take this square's area plus this one plus this one plus this little one, it should equal this one, and this one. So the area of the squares on top equals the area on the bottom. The line goes right down the middle of that area, and presto, you have the best line of fit for the scatter plot. Now remember lines from Algebra 1, lines from Algebra 2, lines from all of your algebra classes. Y equals mx plus b. M is attached to the x, so it's the slope. B is the y-intercept, meaning when x is 0, where would it cross the y-axis, called the y-intercept. This is back for our lines of best fit. Okay, we just changed the letters a little bit for this class. We don't use M, we use A instead. The letters might have changed a little bit, and you might see it in two different forms. Our first one is the most popular for us. Y equals ax plus b. A is slope, b is y-intercept. B hasn't changed, so A is now just the slope. Now, it is important to know what really slope is, because people understand y-intercept. If x is 0, that's where it would cross the y-axis. Y-intercept, where it crosses the y-axis. Slope, people don't always understand. Slope, the value of A, is attached to the x. So this actual value of A is how much does the y change. You might have heard, remember, change in y over change in x is the slope. Or delta y over delta x, or rise over run. Well, technically the value of A itself is if the x just changes by 1. So the slope of a line is how much does y change when x changes by 1. It goes up by 1. When x goes up by 1, how much does y change by? Let me just show you that in a picture. So if you wanted to talk about a line, so if you had any line out there, so here is our plane, here is our line. To understand what slope is, it is the value of A is how much does y change, that is the value of A, when x changes by just 1. It's rise over run, but just think the run is 1. So A is the change in y value, the y, when x is 1. So we're going to find the equation of the line using a calculator. So here's the steps for using a calculator in number 1. And number 2 is using these formulas to get the slope and y-intercept. But you will be doing this on a project more so than on the upcoming Chapter 4 test. This will be on the project afterwards. For the test, focus on using your calculator. How does it work? First, we've done this. Look, we have entered our data into the calculator, x in list 1, y in list 2. We did that last section. Then it says go to stat, calc, lin reg, y equals ax plus b, and then you get the a and b value, which is your slope and y-intercept. We did this exact thing to get our r value. It is the exact same thing as the r value. Nothing new. The second way to do it is to use these values we got before. We got these when we started correlation. We got x bar, y bar, sx, x, sy, and we got slope last section. So they're basically saying you can also get your line using this little formula for slope and in this formula to get your y-intercept. We will do this on a project. We won't be doing that for our upcoming test. So, if you want to take a look at the textbook for detailed instructions, they're on page 174 and 175. This is back to the notes we did. We did this by hand. Remember, we found that long correlation by hand for that archaeological femur versus humerus for that species. Well, what we're going to do is, we're almost done. Stick with me. This is the most important part. We are going to use the calculator in order to find the line of best fit and our correlation. Just a reminder. So, you turn on your calculator. Yes, if you have to use your phone app, the Graphen Calc 83 will do the same thing. So, you press stat, you press edit, you put in your x's in list 1 and your y's in list 2. We did that last video tutorial and we've done it many times. Now we just go to stat, calc, lin reg, and there's our equation, ax plus b. You press enter, you make sure it's list 1 and list 2, or if your calculator doesn't have it, you just press calculate. And this is where we get our important stuff. Let's see how to make the line of best fit. And then let's go over the important thing right away is your correlation, your value of r. Remember, that's the strength of the straight line. You just take that straight up. The line here is y equals ax plus b. Y equals ax plus b. A is the slope, b is the y-intercept. All we do is take the two numbers and put them in their place. So the final equation for this line of best fit is y equals, you take a and you put in 1.1969. So if you round this anyway, it's going to be like 1.2, let's say. 1.2. Bring the x straight down, and then put the b in, plus a negative. Well, if you could, plus a negative is really just minus. 3.65 becomes 3.7. And there is the line of best fit for the data that we did last time by hand. So we get the R by calculator, we get the line of best fit by calculator. So a lot of work saved here. So I'm going to write this down, y equals 1.2x minus 3.7. And our last part of today is once you get this line of best fit, what do you do with it? And it's called prediction. Prediction is taking a line of best fit and putting an x into it to try and predict what y would be. Meaning, you take the y equals 1.2x minus 3.7, and let's say you got a new femur bone, right? That was our x. Let's say you got a new femur bone, and the femur bone was an x is equal to 50. Let's say x was equal to 50, and you wanted to predict what would y be. That is the purpose of the line of best fit, because you can say you take 1.2, you put in 50, and you subtract 3.7 from it. In order to do that, you would take out your calculator, which I'm taking one out right now. You do 1.2 times 50 minus 3.7, and the estimate, our y estimate, we call that y hat if you really want to get specific. An estimated y is 56.3. So that's what a prediction is. It's here's an x, predict what the y would be to go with it, even though it wasn't in the original data. So prediction is based on fitting the line and fitting the data. Prediction works best when the model fits the data closely. What does that mean? What does the 2 mean? This would mean it's best when R is good. And our R value for the femur humerus was in 0.9, very strong. So you want a strong R. The last thing is, the last one, the important one. I'm at the end. Prediction outside the range of the data is risky. What does that mean? It's easiest to understand that if you look at data. It says prediction outside the range of the data is risky. This is all based on the X. And what you do is you look at the lowest X and the highest X. We call that the range of the data. 38 through 74 is all good to go. And then you can even go a little bit lower than 38 and a little bit higher than 74. What does prediction outside the range of the data is risky mean? It means if someone said, oh, what's 100 gonna go with? Meaning if X is 100, what's the Y? Or they say, oh, what if X is 10? What would be the Y to go with it? That is too far outside the range of the data you're working with. It could get very risky. Okay, it could get very risky. So if, for instance, if someone found a new femur, and its length was only X value of 2, so it was a little baby. If I was to do Y equals 1.2 times 2, right? If someone got me a new X of 2, and then subtracted 3.7 from it, it would be 2.4 minus 3.7. What would that be? It would be a negative number. See how my prediction line wasn't useful for 2, because there's no way someone could have a negative humerus length. So keep it in the range, meaning don't go much lower than 38, don't go much higher than 74, and your prediction line will be perfect. You are going to test this right now, so have your calculators out. You're going to do a quick video check, and then you're going to do classwork 27 through 29, and that's the first half of 4.2.